this is Julian at Mecanum, and today I'm going to do a 3-layer simulation using Nova software, so using the transfer matrix method. I'm now in Nova interface and I will create my project. So now in the first window, I'm in the database window. This is basically where I will create my material or select material from my database. I have frequency dependent material, standard material, isotropic elastic, porous cell, damping layer. I have already assembled material or layer like a double porosity layer or so on, and I also various type of excitation that I can create. So this is really my database with everything. I will create two acoustic material. For today's example, I characterized felt as well as foam. So I'll start with the felt. Second material is a foam. Okay, so now I created my two material. Here on the right you can see there is a quick visualization tool. What happens if I increase the thickness of my material? What happens if I change the angle of incidence of the acoustic wave? Okay, yes, so now I can go and create my multilayer. So I'm now in the noise control treatment designer module. This is where I will create my multilayer. Add my here. Okay, and now I need to add material in my multilayer. So I will go here and select my material. Okay, so here I enter the default thickness because I know I characterize exactly this foam thickness. I can change it here if I want. But for today's demo, since I want to do validation, I will leave it like that. Okay. I have my gray felt. I will put another layer of foam. Now I have my 3-layer material, foam, my felt, and another layer of foam. Okay, I can create as many multi-layer as I want if I want to compare different concepts. For today's example, I will only create one. And now I'm in the solution set module. This is where I will really create my problem. In my case today, I want to do an absorption problem. So basic, the most common type of problem, and but I can also do transmission loss, radiation efficiency test, insertion loss test. It really depends on what I need. Okay. So now you can see there is the solver, transfer matrix method, or finite transfer matrix method. I will select transfer matrix and model an infinite panel. My frequency domain, I can select do I want to analyze things in third octave band or in different frequency range. Since I want to compare with an impedance tube, I will select linear scale, narrow band, and I can also change my frequency domain here and add other frequency domain For example, here I want to go to 6,000 Hertz or 20,000 Hertz. I can write it here. And if I come back, it changed. So 100 to 6,000 Hertz. I'm in the air and I want to use plane wave excitation to reproduce what's in an impedance tube, since I did my validation test in an impedance tube. And I come here, select my multi-layer. I have my hard wall. That's exactly what I want for today's example. It could also be fluid domain or cavity. We'll leave it like that. Now my problem is complete. I just need to solve it. Computation is very fast. It's the big advantage of transfer matrix. I can also visualize the impedance and the reflection coefficient. Now let's compare it with the experimental result. Here, as you can see, in red there's the simulation, and in gray the measurement I did in an impedance tube to compare it to my simulation, and the agreement is pretty good. I hope this video was useful for you. Thanks for listening and see you soon.